Okay, let's do the fifth question. The fifth question is tan inverse 1 plus x squared whole root minus 1 by whole divided by x, okay, where x not equal to 0. So this is the question. So now when you look closely, you can see that this whole thing resembles the property, that is tan inverse tan theta is equal to theta. Okay, so if we convert this expression to tan theta, so we can simplify it to this form. Okay, so for that, now let's take x is equal to tan theta. Okay, x is equal to tan theta, so we can write this as tan inverse 1 plus tan square theta whole root minus 1 whole divided by tan theta. Okay, so now if we look close, that you will see that this expression resembles the trigonometric identity, okay, the Pythagorean identity, that is 1 plus tan square theta is equal to secant square theta, where secant theta can be written as 1 plus tan square theta whole root is equal to secant theta. Okay, now let's substitute secant theta instead of 1 plus tan square theta. Okay, so this can be written as tan inverse secant theta minus 1 by tan theta. Okay, so now let's divide. We know that 1 by cos theta is equal to secant theta. Okay, and sin theta by cos theta is equal to tan theta. So instead of secant and tan, we put this. Okay, so we can write tan inverse 1 by cos theta minus 1 whole divided by tan theta, can be written as sin theta by cos theta. Okay, now let's take LCM of the numerator here. It becomes tan inverse cos theta once 1 minus 1 cos theta whole divided by sin theta by cos theta. Okay, now this cos thetas get cancelled out. You get tan inverse 1 minus cos theta whole divided by sin theta. Okay, now again, if you look, you can see that this 1 minus cos theta resembles to a trigonometric formula, that is sine square theta is equal to 1 minus cos 2 theta whole divided by 2, or you can write 2 sine square theta is equal to 1 minus cos 2 theta. Okay, but here you see that we have 1 minus cos theta, but here it's 2 theta. So let's divide the 2 theta by 2, and here both sides by 2. Okay, so this becomes 2 sine square theta by 2 is equal to 1 minus this 2 and 2 get cancelled cos theta. Okay, so now we can substitute 2 sine square theta by 2 instead of 1 minus cos theta. Okay, same way for sine theta, you have a formula that is sine 2 theta is equal to 2 sine theta cos theta. Okay, so we can write, but here we have sine theta, so we divide 2 for the thetas, so we get sine theta is equal to 2 sine theta by 2 cos theta by 2. Okay, so we'll substitute 2 sine theta by 2 cos theta by 2 instead of sine theta. Okay, so we'll get here we'll get tan inverse 4 minus cos, we'll get 2 sin square theta by 2. 2 sin square theta by 2 all divided by, for sin theta we get, for the sin theta we can write 2 sin theta by 2 cos theta by 2. Okay, this 2 and 2 get cancelled. One sin theta here and one sin theta here get goes cancel out, so the remaining sin theta by 2 and cos theta by 2. So we can write tan inverse sin theta by 2 by cos theta by 2. Okay, and you know that sin theta by cos theta is tan theta, so we can write this as tan inverse tan theta by 2. Okay, now this expression has come to this form, the property tan inverse tan theta. Okay, so we can write tan inverse tan theta by 2 is equal to theta by 2 if theta by 2 belongs to the range of tan inverse, that is minus pi by 2 to pi by 2. Okay, now here they haven't given any condition except x not equal to 0, so we can take the condition of the tan inverse tan theta where theta belongs to minus pi by 2 to pi by 2, the range. Okay, so theta belongs to minus pi by 2 to pi by 2. We can write this as theta is greater than pi by 2, less than pi by 2, is greater than negative pi by 2. Okay, but we have theta by 2 here, so let's take now one more thing. Theta here they have given the condition theta belongs to minus pi by 2 to pi by 2. Here they have given theta not equal to 0, so theta belongs to this but not 0. Okay, so minus pi by 2 to pi by 2 and minus 0. Okay, so we can take, now we have theta by 2, so let's take theta by 2 less than equal to minus pi by 2 all divided by, here was 2, less than pi by 2 all divided by 2, since this is theta by 2. Okay, so we get this as minus pi by 4 less than theta by 2 less than pi by 4. Okay, now the range of our expression theta by 2 belongs to minus pi by 4 to pi by 4. Okay, now when you look the ratio chart, okay, you can see that this is minus pi by 2 and this is pi by 2, this is 0. The range of tan inverse exists here, okay, this whole area, but here theta by 2 is in the range minus pi by 4 to pi by 4, okay, which is in the range of the tan inverse. So we can consider this. Okay, our theta by 2 exists here, this range, which is in the range of the tan inverse, required range. Okay, so we can say that pi by 4, this range is a subset of this range. So we can write tan inverse tan theta by 2 equal to theta by 2, since theta by 2 belongs to minus pi by 4 to pi by 4, which is a subset of minus pi by 2 to pi by 2. Okay, so we have now theta by 2. So we have taken x is equal to tan theta, isn't it? X is tan theta, so we can take theta is equal to tan inverse x. So instead of theta you can write tan inverse x by 2. That can further be simplified as tan inverse x 1 by 2 tan inverse x. Okay, so this is the answer.